chemical waste can be classified to one or more of the following hazards: corrosive, flammable, reactive, and toxic. Waste should be best managed from the most desirable to the least desirable methods. The most desirable method is to reduce waste production at the source, for example conducting smaller-scale experiments. Other methods include recover and reuse the waste on site, such as recycling of reagents or waste to be used for experiments again. Recycle the waste off-site or treat waste to reduce volume or toxicity. The least desirable method is to dispose waste into the environment or landfill. To process waste, it should be managed using the following steps. First, identifying the chemical properties of the waste. Second, segregation of chemicals based on its properties. Third, knowing the type of container needed to store the waste. Fourth, labeling the waste with essential information. Fifth, storing the waste at a holding area. Lastly, treating the waste to reduce reactivity or toxicity before disposal. For the processes from A to E, they are usually managed by the laboratory staff. As for process F, it can be managed by both the laboratory staff or the waste disposal vendor. Waste identification. It is very important to first identify the chemicals or materials used in order to identify the characteristics of waste it may produce. Characteristics of the chemical or materials can be obtained from the Safety Data Sheet, SDS, and the Globally Harmonized System of Classification and Labeling of Chemicals, GHS. This is to ensure that the chemical or its waste characteristics are communicated effectively for safe disposal. Proper segregation of waste gives rise to good chemical hygiene and creates a safe workplace environment. Only put compatible chemicals in the same waste container. Do not mix solids and liquids. Do not mix halogenated with non-halogenated chemicals. Incompatible chemicals should be stored in separate containers and placed in different rooms to avoid disaster should leakages occur. Do not store the following near each other: acids and bases, strong oxidizers and organic compounds, powdered or reactive metals and combustible materials, water reactive chemicals and water or other chemicals. This chart is used to determine compatibility of chemical waste storage. To read the chart, first, identify the type or class of the first chemical waste for storage on the top row. Then proceed to identify the properties of the second chemical waste for storage at the right column. Look for the intercepting point between both chemical waste properties. Based on the remarks on the intercepting point, refer to the legend to determine compatibility and storage recommendations. For this example, flammable waste cannot be stored with oxidizing waste and have to stored in separate compartments with fire rating of 2 hours. Remember, mixing of incompatible chemicals may result in explosion, releasing of harmful gases, corrosion of waste container, thus leakage of waste, releasing of excessive heat from exothermic reaction, ignition or fire. For example, mixing incompatible chemicals such as nitric acid and ethanol in a waste container can form an explosive mixture. If a bottle broke in a waste storage area where incompatibles were present, the results could be disastrous. Remember, incompatible bottles of waste should be stored separately. The objective is to avoid accidents in the laboratory. Waste containment. Containers used to hold the waste must be compatible, not reactive, sturdy and leak-proof. Liquid chemical waste which are stored in primary container should be placed in a secondary container. Primary container should be filled 3/4 full and sealed tightly with no parafilms. The secondary container should be able to hold the 110% of the volume of the primary container. These are some examples of chemical wastes which are compatible and incompatible for storage.